AUTOSAR. AUTOSAR Classic Platform R1911. Software Architecture. ECU Abstraction Layer. The ECU Abstraction Layer connects the drivers of the microcontroller abstraction layer. It also contains drivers for external devices. The layer is divided into 6 model groups. The onboard device abstraction group contains drivers for ECU onboard devices which cannot be seen as sensors or actuators, like internal or external watchdogs. Those drivers access the ECU onboard devices via the microcontroller abstraction layer. Here you see an example for watchdogs, which uses the internal watchdog driver and the SPI handler driver. The main task of this group is the abstraction from ECU-specific onboard devices. The memory hardware abstraction group is a group of software modules which abstract from the location of peripheral memory devices, which lie on chip or on board, and the ECU hardware layout. The example shows how internal EEPROM devices and external EEPROM devices are accessible via the same mechanism, using the internal flash driver, the EEPROM driver and the SPI handler driver. The main task of this group is to provide equal mechanisms to access internal and external memory devices as well as internal and external types of memory hardware. The crypto hardware abstraction group is a group of software modules which abstract from the location of cryptographic primitives, which can be internal or external hardware, as well as software-based. The example shows how the advanced encryption standard primitive is realized in SHI, or provided as a software library. In this example the crypto driver and SPI handler driver are used. The main task of this group is to provide equal mechanisms to access internal and software cryptographic devices. The wireless communication hardware abstraction group can be seen as part of the communication hardware abstraction group or as a separate group. The example shows how the wireless communication hardware abstraction interfaces drivers for the offboard communication services. In this example the involved drivers are the wireless Ethernet driver, the SPI handler driver and the DIO driver. The communication hardware abstraction group is a group of software modules which abstract from the location of communication controllers and the ECU hardware layout. For all communication systems a specific communication hardware abstraction is required, for example for LIN, CAN and FlexRay. The communication drivers are accessed via bus-specific interfaces, for example via the CAN interface. Here you see an example for the CAN bus. In this case the SPI handler driver, the CAN driver and the DIO driver are used. The main task of this group is to provide equal mechanisms to access a bus channel regardless of its location, which can be on chip or on board. The input-output hardware abstraction group is a group of software modules which abstract from the location of peripheral input-output devices and the ECU hardware layout, for example microcontroller pin connections and signal level inversions. The example shows how the different input-output devices might be accessed via an input-output signal interface. In this case the SPI handler driver, ADC driver and DIO driver are used. The main task of this group is to represent input-output signals as they are connected to the ECU hardware. These signals could be for example current, voltage or frequency. Furthermore the layer hides ECU hardware and layout properties from higher software layers. We can see that all groups offer an application interface for access to peripherals and devices regardless of their location and their connection to the microcontroller. The main task of this layer is to make higher software layers independent of the ECU hardware layout. If you want to learn more about AUTOSAR and other interesting topics, go to embeddedacademy.com.